Sorry about that. The stream just crashed, but nothing too untoward was lost there, and I noticed it straight away, so we're good to go. Um, so anyway, rolling back to what I was just saying, I was talking about how the whole concept of getting this state out using this little function, like technically it works. So if I get this building and now run it in here, I'll just put this over onto the right hand side, top to the right, and look at the console. So if I reload here, you'll see it gets that object, right? And yeah, that object gives us an idea of where we are, that loaded location and all that sort of thing. And in fact, what we could do is make that available to window. It's not going to let me do that normally, so I have to give that an as any on it. But what I could do, so if I make that available, any old time, I could get a hold of that get router state and see that. So you can see here we've got that loaded location and the current loaded location, which is entry 2. All very well and good, right? But the problem with that is it's very simple in the early days, and then it grows in complexity again and again. Because in order for me to know that this state has changed, I need to register some sort of listener. So if that was the case, then maybe you'd eventually have some sort of register listener function, right? And you register your own function. And I'm just gonna slap this out real quickly. So if we had, say, listeners, and every time you register a listener, that gets put onto the stack of listeners. Dot push that function. So now we have some way to potentially listen to things. So let's say we go register route listener. Yeah, we'll call that register route listener over here. And then we'll register that function over here. So what we'll do with that is then we can register our own function, let's say. So we'll go register route listener. And all that is going to do is console log the router state. Oh, router listener. There we go. Thank you, TypeScript. Always got me back. All right. Did I do something wrong here? Register router listener? Register route listener. Ah, no, I did something wrong here. Right. Again, thank you, TypeScript. All right. So if we register this route listener, now what's going to happen? Well, nothing yet until we start calling it, but that gives us a way to listen to what's going on. Now, if we say every time we expected update view to happen, so every time we did something that updated the view, and I'm gonna like sort of just keep this really simple, just so that we're not like I don't want to dive all the way in. So every time something happens to the router state, what we're gonna do is over all of those listeners, for each of them, we're going to call them. That's all we're gonna do. We're gonna call them. That's it. So let me move the listeners back up here. No listeners will ever be on the list there, but anyway, that's fine. Okay. Very good. So now we have these listeners hooked up. Might as well get rid of that error so TypeScript stops complaining to me. So every time we run that, now what's going to happen is we should get a console log out of that update view. You can see that just there. And then I'm going to move again. You can see it just there. Now, I didn't register, do an update for when when the page actually loads. So I didn't put the listeners in there. So that's obviously something I've missed. So that there's yet more details that they're going to be for subscribing to these changes. So there's some way for the app at large to sort of listen to what's going on with the state change. But the thing is, if we were to jump over to the old Blackboard here, if we had, all right, let's. Oh no! I thought it was going to set up my my tablet correctly. I'm just going to fix my tablet real quickly. All right. Anyway, while I'm doing that real quick, what I'm going to do is talk about. So when it turns out, when you end up doing this, like the first time it seems really simple. The second time it seems a bit annoying. The third time it's still a bit annoying, and then eventually it grows to a point where it becomes unwieldy, and that's what I'm intending to demonstrate just here. All right, that's much better. Okay, so if we make this day 5, so if we have, so all we have at the moment is we have our router, and then we have app main. And this has a little bit of state. This will eventually have a bit of state. We'll probably have a localized service in there. That will have a bit of state. And then we'll probably do some more. We'll have some database state, like requests that are outgoing and stuff like that. Just records in general. UI state. You know what, I'm not going to list it all out, but I can assure you that I could just keep on going down and down the page if I really wanted to fully go through all of the things that are going to have state, right? Now, if every one of these, when it undergoes a change, needs to subscribe to various things. So say we had a change happens here and we put a function on app main to listen to that, all right? So there's one link right there. But what if other things care about that? What if, say, UI state cares about it? So now that's going to have to listen. And what if... it's a pain that does that. Anyway. And what if localize had to listen? But it probably won't. What if databases had to listen? And records. Okay, so that's all of the lines of the communication from this sort of change happens, update all your listeners sort of pattern. Well, if that's the case, then we're going to have to do the same for maybe localize, right? So now we've got these connections. And then we'll do it from database. I'm not even going to count how many lines I've created here. It's already looking a bit complicated, right? So there was a time when we tried to make applications like that. All right? There was a time when that was considered sort of standard pattern, and it would have some sort of model view controller pattern. The idea being that model being the database model, and then view being a view into that. I mean, there are a lot of explanations for what MVC could mean. So even if I say that, someone's going to go, no, MVC is something else. But either way, there was this concept of trying to compartmentalize your code in various ways. And what ended up happening, especially for a large, complex application with a lot of UI things happening, is things would end up out of sync. Because all it takes is for a couple of these listeners to have some bugs in them. And what ends up happening is data just doesn't go where it's meant to. And that's a big problem, especially for the user, because things might be inconsistent. They might need to refresh in order to get their data back in order. It's not a fun time for everyone. So the alternative for that is to just put all the state in one box and tell every various service, whether it's the app, the router, what else? We've got the the localize service, got UI state, and records. We take all of them and just say, look, you can grab your state from this big old box of state. So you can grab it whenever you want. And in addition to that, you can listen to it whenever you want. So what ends up happening is a lot less links. So none of these things talk to each other. If they have an update to send, they send it back in through a common place that's going to handle all this stuff. And then the state dispatches out to all of these. In fact, I'll change the color of that one. So anything that's just something reading is blue, and red is the dangerous stuff where writing happens. All right, so state can be grabbed by all of those things, and whenever an update happens, it is not allowed to be pushed up straight in, right? So any update actually goes all the way around into some sort of controlling function that essentially makes sure it matches the right state, that there's nothing wrong with it, and then runs an update on this global state. And this global state will have information about all of these things. It'll have information about the app. It'll have information about the router. It'll have information about localization. It'll have UI state, and it will also have records. All of that's in there, but the key thing is all of the smarts in terms of your interaction of whether the state is updated and what all the state is all comes from this bucket rather than from all the different separate concerns. Because here, there's a lot more lines of communication, there's a lot more places for things to go wrong. Here, it's a little bit easier to eventually track what the hell is going on and what is changing your state over time. So in order to have this single point of control, there was a lot of different cracks at it, stuff like Flux, and eventually though, Redux became quite popular. And Redux itself, I mean, it's very simple library. And in fact, we might even try and write a little one before we bring in the actual library, just so we can demonstrate how simple its concept is. And in fact, that might be best. So we will figure out how we're going to get state to the rest of the application. And then eventually we'll try and adopt this pattern of in-memory storage using it. So, and just to be clear, this is about in-memory storage, which means just variables that exist, objects that exist within JavaScript memory. We're not talking about like persisting. Every time you refresh, all of this information goes away, because that is what we intend, right? Okay, so I'm going to chuff off of here. I'm going to quit everything. And I'm just going to make a directory first. So inside, client I call it in this one. All right, so we're going to make a place called state. Jump back into Vim. And first of all, I'm going to get rid of all the vandalizing I did of the router function, because we don't want this concept of listeners or all that. We're gonna abandon that for now. What's it? App.ts. That's right. Okay. So what we're gonna do is stop getting a hold of all this stuff. So yeah, just gonna remove all this. What am I doing? Get rid of all of this code I didn't really want to write in the first place. It was just for demonstration's purpose. And I'm going to get rid of the concept of listeners here, and here, and here, and here, and here, and here. And in fact, I'm not going to return anything. So I'm back to where I was. What I'm going to do from here is look at our state folder. So that's client, platform, state, index.ts. And what we're going to do is investigate the concept of how Redux as a library works first, before I even introduce the library itself proper. At its core, the Redux itself is about the concept of a reducing function, or a reducer. And that reducer takes a variable called state and a variable that is an action. Okay, and that can also be anything, but we will eventually have some rules for what an action can be. Now with this state, because this state can be anything, So it could be a literal number, although that would be a very simple line of state. It could also be an object of some description. What we're going to do is start off with that state being a literal number, right? Something as simple as humanly possible. The whole idea of this is that when you have this function, every time this function gets called, the action is what's going to tell it what to do, what change it's going to make to the state. And this is the way that we control how data goes into the system. So let's think of a couple of really simple actions. Let's call one which is called increment. So it's going to have a string, a string on it called type increment. And then we have a decrement action. Okay. So with these, whenever this comes into our reducer, what we're going to do is tell the number, the state, that number, to do something, right? So if action.type equals increment, then we're going to return state plus 1. Else, if action.type equals decrement, we're going to return state take 1. And if neither of them match, so we could put an else on the end of that, we just return the state, because the action, whatever action we received, shouldn't change anything. So we just return the state. So possibly, rather than doing this in the console, I might do this through testing. It might be an easier way to demonstrate what I mean here. So state.test.ts. Remind myself how Jest runs its tests. Routing.test.ts. Okay. Excellent. Okay. So if we just have a state dot, just pull these functions in real quick, and then I will grab state/index.ts. So here we're going to just test what this reducer does, right? So if I go and clear all this out and say increment action changes state to 1. All right. So we're going to import. We've got to export all this stuff. So if we export that, and we'll grab our actions and our reducer. And I think that's it. Yeah, that's it. From index.ts. So if we have a state of 0, and we have, yeah, actually that's all we need. All right, so if we have state step 1 equals reducer, and then we feed in state, and then we get the increment action. So we would expect state step 1 to equal 1. Okay, and I'll talk about, like, I know I'm trying to figure out what exactly the right lane to approach this, because people can get really intimidated by what goes on with Redux sometimes, especially once you scale it out in a big way. But this is where we start talking about functions in a really pure manner. And by pure, I mean that the function doesn't have any side effects. But anyway, let me run yarn test. So it's going to run all these tests, and apparently all of them were good. Okay, so what I'm going to do is going to change this to 2 instead, and we're going to see. So it received a value of 1. Okay, so I want to be really clear on how this works. When you have the concept of Redux, you have a state object and you have actions that you feed into it. And every time you have a new state object, you end up with steps happening. So that action comes in. The functions inside a reducer are meant to be pure, which means there are no side effects. They're not allowed to do anything else other than return the new state. That's this guy right here. And that new state shouldn't mutate the old state. It shouldn't change the value of this one. It should return you a whole new state. So if we have ourselves state step 2 here, and we run increment action, then we accept state step 1 to equal 1, and state step 2 to equal 2. State step 2 to equal 2. So if we run this, we should have a passing test. So let's just test that. What did I do wrong? Oh, maybe they're calling each other because... Ah, right. So see here, I should have passed it state step 1. That's what I should have done. Okay. That actually further proves my point. But anyway, let's keep going. So every time you change the state, you meant to, like each of these steps matters, right? And if we say state step 3, and in it we pass state step 2, and now we have a decrement action. So what would we expect state step 3 to be? Well, if we are at 2 here, so this becomes 1, and this becomes 2. If we feed the state a decrement action, we would expect it to take 1, which equals 1, right? And we run the test just to make that really clear that is how it ended up working. So that did, in fact, pass the test. And that's how this is meant to be, is that if we were to do something like this, then we could do something like all of these states. We could see this progression over time. We could see how the application changes its state over time. Of course, this is just a number, but let's say if we console log that, you can see here, we can see each step of the way. Now, this requires us to follow certain rules that are really important. So if we go back into state index.ts, and instead of having the state look like this, where it's a number, we instead have an object. Okay, so that object is going to be count 0. Now, if this is the case, so if state is count, then we cannot do something like this. So if we go state count count equals state dot count plus 1 and return state. So I'm just going to do this really quickly just to show how not to write reducers, or the concept of reducers. Okay, so now that we've done that, we've got state.count in there, we've got something a little bit different. So now that the state has this concept of count, we're going to check that this can pass. And we're going to run into some trouble. In fact, I'll put this up here just to make that clear. So when we run Redux like this, with these side effects happening in the object, you will see that this now has count 1, count 1, count 1, count 1. That's wrong, okay? We don't want that. So that all ended at the last step. That decrement is where it ended up at 1. What we really want to have happen is every single time we step in a reducer, it's creating a new object, or it's changing the part of the object which matters, so that we end up with a new item every time. We don't end up changing old data. We always are moving forward with new data. And what that would mean is we could, what we would want to do is instead return a new object every time. And there'll be more complications with this when we start looking at how to handle. Let me just say that there is a lot of prior art in this department in terms of how to do this properly, and especially once you start getting in larger and larger applications. But we're not gonna stress about it too much just yet. Now, so if we bring up that count there, but if nothing changes, we're happy to return the old one because we know nothing in fact changed. And I'm going to add a nothing action, which doesn't do anything. And the reason for this is just to demonstrate the fact that if a nothing action happens, then nothing should change in between those two steps. All right, let me get back to the tests. Or the test, rather. So now, if we run this test, I would hope that everything should work this time. So we passed our test, and you can see here with this console log output that we can see each state step. So this is state step 1, and step 2, and step 3. So every single time this happens, we end up with new state coming in that represents what things should look like here. That said though, if nothing changes, we don't need to change anything, and that's something that can be demonstrated by putting in one of those nothing actions. So we should be at 1 at this point, and we need to feed in state step 3. And I'm just going to put the test on it to check it. So this time, you can see count 1 did not change because it was a nothing step. What's even more interesting about that is because we know that nothing changed, state step 4 is not only equal, it is actually state step 3. Because it didn't need to change. Why would it change? We don't need to run any mutation. Okay? So we know that if we console log it now, state step 3 equals state step 4. In fact, we can just do double equals rather than triple equals. So if we run that, you can see that's our console log there, and it ran out as true. Okay. So the concept of reducer is this function, this action. It just keeps on getting called, and in addition to that, we just have some things wrapped around it, which handle the whole concept of passing this on to someone else. So the whole idea of passing it on would just mean that there is some sort of listener out there that is listening for when changes happen, and then saying, all right, I'll do whatever it is that you need me to do. And that's great. With all that set in theory, what I want to do is try and get something simple running, and I'll try and do it with Redux, I think. So what we're going to do is we're going to bring ourselves in a new dependency. That new dependency is Redux, and we'll add it as a non-development dependency because we'll probably need it in runtime whenever we have any server-side rendering or anything. Okay, and the types are in Redux, so we probably don't need to add the types, but we may as well do it. It's a stub, but we'll add it. So yarn add types Redux. Those are only needed for development. Oh yeah, you don't need types Redux installed. Great. Okie dokie. So if I jump back to, okay, yeah, so we're in state index now. So this concept of reducer, we just sort of built the reducer, But all we need to do to have a little bit of, to actually make use of Redux to do the work now is we need to create a store, import create store from Redux. And that provides us just a little bit of extra smarts to essentially handle everything. So what are we going to do is going to export a default function now called create state store. And it's going to accept an initial state, which will probably look something like count 0. And that's going to create what Redux refers to as a store. Yep, create store. So our reducer is called reducer. So that's this function right here. And our initial state is going to be this right here. And then we're going to return the store. And you're going to see why I'm going to do that, why I'm doing all this real soon. Because I'm going to jump into app.ts and I'm going to get that store. I'm going to get it. So create state store from platform/state. And this will eventually get more complicated, don't believe me, because I need to be able to handle all these different components and I have to deal with them in such a way that they don't really have to know about each other too much. So there will be a better way to handle creating this store real soon. But for the moment, what we're going to do is we're going to create our store with const store. And we're just going to give it an initial of count is 0. Now, we shouldn't end up with a crash if we jump over to here. And we don't. Very good. And if I, what I'll do is I'll just start off with a store get state. And what you'll find is that will give me this object, this count object here. So anytime I want, I can call get state and get that state, put it into use somewhere. Where would we want to use it? Well, let's say that we want to use it in our routes. Then maybe we need to pass the store in there. But in fact, I might be jumping the gun if I try to do that. So give me a moment. I will get there eventually. For the moment, what I want to do is demonstrate how this concept of listening operates. What we'll do is we'll create a... we'll put something on window that allows us to call the store. In fact, we won't make a call the store because we don't really have a way to make use of that. So let's instead, I'm going to give us some actions. Increment action, decrement action. And I'm going to put something on window that'll let us play with it in real time. So the state stuff, what state stuff have we got? We've got increment action, we've got decrement action, and we've got the store. All right. And this is going to give us just enough to be able to play with the state. And lastly, what I'm going to do is add myself a little subscription function. So this subscribe function, that is these lines, okay? So every time you want something to listen to the state, that is that subscribe function. And preferably you do as few of these as possible if you can, because you don't want you want to do these in a fairly simple manner. So you don't want anything complicated passing between them. You only want to be subscribing to the store. And the idea is if we're using the store as our source of truth, if all of this information is passing there, we should be able to depend on it for the most part. There are reasons why you wouldn't for every single thing you do on the site, and we'll get into that when we go a little bit further into the concept. But for now, think of this subscribe function as our way to get a window into the whole state of our application. So with the subscribe function, we're just simply going to go console log store get state. And then we're going to run this up. So I should be able to, if you look down here, should be able to find state stuff down here. And you'll see here, I've got my actions here and then my store, and that's got a bunch of functions on it. So if we were to grab state stuff, grab the store, and then dispatch. Dispatch is our way of calling the store and telling it to feed this action into the reducer. And so I'm going to pass it state stuff dot increment action. And you're going to see here that we had ourselves an increment. So it came up to count 1. And if we do it again, count 2, count 3, count 4, count 5. Great. What about decrement action? Will that bring it down? So the power here is that literally nothing other than the reducer is allowed to change the state. And what that means is, while everything can tell the reducer what to do, the reducer is in charge. So it turns out that's a great way to safeguard the rest of your application against like some bad module having some sort of race condition with something else and things getting out of sync in some way, shape or form. If all of your data is forced to go round into this gatekeeper and then through to state, and then finally it gets through to all these places, there is not only some intelligent things you can do to reduce complexity there, it ends up being a lot easier to be sure about all the data that you're doing. So it ends up resulting in a lot less code. But it's absolutely dependent on you writing good reducer functions that are pure, which means they don't alter things with side effects. They always looking forward. Now, there is some benefits here for tooling, which is why we're going to be using Redux specifically. And I do wonder if Firefox Redux DevTools. I do wonder if there's Firefox Redux DevTools. Yes, there is. So we're going to make use of this. Give me the DevTools. And let's see if I've got them already. Yes, I do. Excellent. Okay. Now, these are pretty great. Pretty great. I'm going to reload. And I might have to put in some sort of listener in order to make this work. Yeah, there we go. Okay. So for a basic Redux store, we have to add just a little bit of code to make sure that allows us to make sure that we've actually got it. We need something to hook onto the store and listen to it. But this is going to be pretty cool. It's going to be very useful down the track. And we'll see that real soon. Give me my clipboard. There we go. Okay, it's not going to like that because, well, it doesn't like the fact that we're calling Windows with all this stuff. But it'll get over it. Right. So now, if we refresh, we now have the Redux developer toolkit here, or that's probably the wrong word to be using. We got the Redux developer tools, and what that allows us to do is keep a close eye on things. So I can do this decrement, I can give me increments. Yeah, here we go. So let's do increments. So I've run this action, I've got these console logs, and I mean console logs could be kind of useful, but they're not nearly as good as being able to do something like this and actually see the change every single time it happens. And you can see the state change, you can click through it, and what's even cooler is you can jump back to a particular stage and your application will update based on that state change. So I mean, that's all very well and good, but it literally only is changing the state here. You're not seeing it here. So maybe that's the big thing that we need to do right now, is do something that will actually change in the app itself. So how about we do that? I'm not going to put this, I'm not going to couple this with the router just yet, because I don't want to run out of time while I'm trying to figure that sort of stuff out, because already it's a little bit mucky, and I want to try and clean up that code, and I'm just concerned I won't be able to do it in 15 minutes. Not properly anyway. So what we're going to do is start off by just changing something around the edges, like weekends web app, and maybe have some counter stuff down here. So what we're going to do is, if I grab my container real quick, and I'm just going to put a little bracket here. No, I don't have to do it here. I'll have a footer and call it counter, right? So in this counter, we're going to have a count. Sorry, I'm going to have a span dot count, and then I'm going to have a button in there dot increment, and I'll have another button called decrement. Now these won't do anything just yet because they're just there, right? Okay, we've got increment, decrement, and we've got a count. We may as well put the number in there. And there we go, we've got the number there. Great, all right. All good, hey? Job done? Not quite. So we've just put them in as HTML, but nothing really happens. I might just put some breaks in here so that there's a bit of gap. Yes, I could do it with CSS, but I don't want it. Now, we want to be able to make that change. So we're just going to throw on something really rough. We're going to have a increment button. So we can get that by going document.query selector and then selecting against the class. And the way we'll do that is with .increment. And we'll also get the decrement button. All right, and now we will add ourselves some really simple little, some really simple event handlers. So we'll go increment button, add event listener, and the event we're going to be listening for is the click. And when that click happens, we're going to prevent the default, because usually clicking a button submits a form. We're not actually in a form, so it's actually probably safe. We don't need the prevent default. But what we do want to do is we want to dispatch an action to the store. So we want to go store.dispatch increment action. Very good. All right, what we also want to do is to store decrement action, decrement button, and this time we want to dispatch decrement action. Finally, I'll get rid of all this stuff because we don't want to interact with it through the console line. Finally, what we're going to do is we're going to take this store subscribe, and we are going to update the count with it. So we need to get that count element. And what we're going to do with that is every single time the store updates, we are going to update that count there. I'm pointing, but obviously you can't see that. We're going to update that count there with the new state. So if we get the state by going state equals store.getState, so that will equal our object, our count object. Pardon me. What we're going to do is to take that state, and we're just going to apply it to that count element. So we're just going to go, in fact, we don't need inner HTML because we're not actually doing any HTML here. So we can simply chuck in state.count. So now if we refresh, I should be able to increment that count at will and decrement. And you'll see all of my actions take place here. And here's where that jumping becomes really interesting, because I can click jump and it will broadcast to the state, it'll broadcast to this, this subscriber that, hey, the state's changed, update. So it ends up being a really handy way to just keep track of everything that's happening, because eventually you can see exactly what changed, what things got updated, and then possibly even track down your bugs, because you can jump to particular places. You could remove particular elements. So if we remove this decrement, then it will be one higher. We skip this one. Whoop. Sorry, it's a bit laggy. I think when I'm recording, it gets a bit laggy. So you can see here, by skipping all of those increments and one decrement, we have changed the final value at this point. And we can also jump ahead. So there's a lot of power here when you start doing this sort of thing. You can see the whole state tree in various points. You can test whether the reducer is in a certain case here. You've got this these various tests that can output themselves for you, which is pretty handy as well. But yeah, there's a lot of power in how these development tools work. So even though Redux itself is quite simple, all of the tooling that's running around it and the fact that it's a very flexible tool makes it quite a stable foundation for us to work from for our global state. That said, there's going to be parts of our UI framework where we don't want this global state concept. It turns out, while this is a really useful idea, you can imagine if the whole app was being updated every single keystroke you did when you're entering into a form, you might start grinding your gears just a wee bit. So it's not always the best idea to put literally everything in global state. And in fact, you will find that I will probably find myself erring towards keeping towards a local state for forms and that kind of thing, and only calling back to the global state when I absolutely have to. Because it turns out that you can really notice the little bits of lag that happen. Even if nothing actually changes and it's really efficient, you'll still notice the really little bits of lag as you're typing in if every time it's going through the whole Redux lifecycle. So with that, we've got 10 minutes left. So maybe what we could try and do, is get this counter into our views, because this is important, right? Like, we need this state to be available to the things that are actually getting rendered. So we'll see how we go. I might not get all the way there, but I'll give it a red hot go. So what we've got here is, at the moment, every single time something happens, it's going through this update view function. So the update view function is the only function that is able to run a render onto a route. And I just want to take a moment to think about how it is that we're going to get state into here. Well, let's do the naive thing, as always. All right, that'll probably end up being a catchphrase for this one if I keep on saying it. But let's do the naive thing and think, all right, we don't actually care about updating it as we're clicking on it. We only care about when the route loads, and we don't care about anything other than this. How would we go about that? Well, the only way we're going to do that right now with the way things are set up is possibly if we pass the store into the router. So let's just do that just for now, just to demonstrate what we could do. All right, so if we jump up to initialize router, this is already not very fun code, so we are going to have to do a bit of tidy up real soon. But if we take that store, we'll just give it a type of any, because I'm not too concerned about types, but more demonstration right now. If we take that store, and every time we update view, we're going to pass view state. The view state, which is actually just store.getState. Just going to do it, just going to pull it in. And we're going to do it here. And we're going to do it here. Have I cleaned that? Yep, okay. So that's cool. We just need to update view now. So if we jump through there, I need to get better at the various TypeScript helpers in Vim, because they'll let me jump around to definitions real quick. Anyway, so we've got this concept of app state that comes in. I'm going to give it an any for now. And when we render our view, we're going to send that app state down the line. So here, where it renders error, we've got params. We can put the app state there. We might actually leave the app state for the render errors, because I'm going to figure out a better way to do all of this anyway. But let's just save it for the actual views themselves. So whenever the view renders correctly, which if we want to see where that is, it's in this try catch right here. So we're going to pass that the app state. And yeah, every route render function is now going to collect an app state of some description. So view render function, no params. Oh no. That's going to make us have to rethink a few things. Like potentially we'll never accept a view render function with no params just because we've got app state in there. So yeah, let's do that. We'll just say view render function has got to be the thing. We can't do no params. And the only place where we need to remove that really is here. So we'll go for app state any here as well. A required parameter. We'll make it optional even though it's technically not optional. Or it's always going to be there rather. Okay. So with this render function, we now have app state. And we can probably get just shiv that counter in here. Like the count is app state.count. And we'll do that for pretty much every one of these views. Jump to 96, chuck that in there. And then we'll go app state again. Do we need that for here? Yes, we do. So again, we're grabbing all that and we're going to take line 97, this app state.count, and we're going to chuck that into the home page as well. So now with all that, if we refresh, we should see the count. Okay, you'll notice it will not update when we change things because we haven't sort of made that code path yet. But if we were to go to the about page, you'll see that it update with that increment. And if we say change that to free, jump back to home, you'll see it there. Jump it up to 7, jump to entry 2. You'll see it again right there. So that gives us a some sort of count passing into the state, but it's obviously not clear yet how all of that is going to come together. So with 5 minutes remaining, we're probably going to pontificate a bit on how we're going to do that, and actually set that into action when we do a proper sort of run through of the state on Friday. So let's have ourselves a bit of a think. If we look at this store and the dispatching concept, all of that, like very important, we need to figure out how to pass these things down to the router. And I think the interesting thing about that is because what we also want to do is we want to extract this state into the router as well. So if that's the case, what's probably going to happen is some sort of case where this router is always waiting, like it's always receiving state. And if we can think about it in this way, so if we've got this concept of state in, what does the router do in response to this state? Well, the first thing it does, surely, is it checks if the loaded location has changed. Because remember, this state is now, instead of the router changing information here, what it's going to do is say, all right, I know that the location has changed. I'm going to send it around here. And then eventually I will hear about the fact that the route has changed in the in some sort of subscription function. I'm going to hear about it over here. So it's going to check if the loaded location changed. And if you want to see what we do with that logic, well, that logic exists in update view right now. So maybe that's a better place to be writing this concept of the code actually. Let me grab state in, and we'll do our commenting down here. Right. So if we check if the loaded location has changed, which is this check right here. Now at the moment it just, it aborts if the thing is already the same. But we don't have to do that. What we could do instead is use that. So if it's changed, if loaded location changes, start loading the new route. What should it also do? So in the meantime, there are other things it can do. So for all visible routes, So if we say kept a collection of all the different locations that are currently visible, let me see. So all these view containers here, if we kept track of all of them, what we would want to do is send the state to all of them. And all of those render functions will get hit at that point. Now, there is some more complexity that we eventually hit there, but that is sort of what the router is going to need to do in a nutshell. So if we do a couple of things, we'll pull the concept of the state out, the global state, we'll pull that out, and we'll have ourselves a small reducer just for the router, a concept of how this state is going to perform under various actions, like when new pages load, when back is hit, that kind of thing. So we're going to take that concept of the router, and then after that, we are going to then figure out how to make it so that we have a subscription function that listens to it, acts appropriately based on that information. So it can start the whole concept of loading a new route if it needs to. And for everything else that is visible, it will just keep on rendering them with new state every time the state changes. That's going to be our goal for next for on Friday, because that is going to be the thing that's going to get us rolling through all of our systems. So that brings us to the hour mark. So if there are any questions, please fire them at me on chat or on Twitter. I'll check Twitter real quick. But yeah, that's pretty much going to wrap up what we've done for today. Oh, I can't do Twitter on that one. There we go. But in the meantime, we may as well commit our bit of a mess here. It's not a great mess, but we will clean it up tomorrow. It'll start looking a whole lot nicer tomorrow. I trust me. Right, we'll be committing state. We'll be committing all of these files. Right. So our commit is for day 5. Introduce concept of Redux. Start reworking router to accept state. And I'll push that on. All right, there we go. So it doesn't look like there's any questions for today. So that pretty much wraps up for today. Tomorrow, on Friday, we are going to start to get this router working as we intend it to, and hopefully the whole concept of Redux will start to look a lot more powerful at that. This dev tool, I mean, it looks underwhelming right now. It is extremely useful once we get into the thick of what we're going to be building. So with that, thanks for watching. As usual, you can keep up with the code by checking it out on GitHub. So that the location for it is github.com/weareoffcider/weekendswebapp. Right there, you can clone that down. I tag all the days so that you can keep up on what's happened on which days of the stream. And we'll be sending this up to YouTube, so you'll always be able to keep up at your own pace. Anyway, that's it from me. Thanks for watching, and I'll see you next time.